Hello everyone and welcome to the channel. I'm Emmanuel, I'm an Airbus pilot, and welcome to this easy tutorial for the iniBuilds A320. Now, I'm saying easy tutorial because I do simplify things in this series. If you're interested in the full-blown version including all the details, I do recommend to have a look at my Phoenix A320 tutorials. Now, this one is made for beginners, so I am simplifying things a bit in here. So now that we've started our descent towards our destination, let's have a look at a couple of the symbology we see on our displays, namely the speed indicator. You can see that we've got the speed target over here, and then we have these little brackets at the top and at the bottom of them. This entire area over here symbolizes the range of speed within which the airplane is going to fly in order to follow the vertical path. Now, if our wind component was significantly different from the forecast, then we might end up at the lowest part of the speed, and in that case the airplane would add thrust in order to maintain the speed. If, however, we were significantly above the profile, then we would fly all the way to the maximum speed and thereafter start to deviate from the path. If you encounter that situation, use the speed brake in order to create additional drag and keep descending. Passing 15,000 feet in the descent, we are going to turn on the fasten seatbelt signs. So switch into the auto position and verify seatbelt shows on the ECAM. The reason we turn them on at 15,000 feet is because this usually marks a position 15 minutes before landing. Now, obviously, if you are about to encounter turbulence, so if you were to fly through some bad-looking clouds and stuff like that beforehand, you can always turn the seatbelts on before that time, but you basically shouldn't turn it on later than 15,000 feet in the descent. Talking about symbology, let's next look at what we have down here on our nav display. You can see that little dot that we see over here. And this dot basically shows us that we reach a speed reduction point. So when we overfly this little point, the aircraft will automatically start slowing down. The next speed reduction we have on our plan is reducing towards 250 knots when reaching 10,000 feet, and that is going to be done fully automatically by the aircraft. Now, at some point, air traffic control will clear you down to an altitude, let's say for example 3,000 feet, and when that happens, you will also be given a QNH. Simply set the local QNH over here. Remember, we also pre-selected it on the descent, so it should automatically already show, but it may be a good idea to run a weather update at this point to be sure that you have the latest possible weather. So in our case, you can see 1008 is the correct QNH. Cross-check that on all three altimeters. Now that we've reached the speed reduction point, you can see our speed target has reduced towards 250 knots, and the airplane is automatically pitching up in order to start reducing the airspeed to match that target. Looking at the navigation display, we can already see another speed reduction point coming, because we have a 220 knot restriction over the waypoint Kopak. Also note that we have a minus flight level 120 restriction, which means we need to cross Kopak below flight level 120. As you can see, we are quite a bit below Kopak already, so for that reason our airplane has met the restriction without any need for any additional help. Reaching 10,000 feet or flight level 100, we once again have a little procedure to run. We are going to turn on the landing light. Note that if you're flying in an area where VFR traffic is allowed above 10,000 feet, for example in the United States it can fly all the way up to 18,000 feet, then it may be a good idea to turn the landing lights on a little bit earlier so that you are easier visible to any VFR traffic. Once the landing lights are on, verify that the seatbelt signs are on, then we move down to the EFIS control panel, make sure that constraints are selected, and if an ILS approach is planned, also activate the landing system push button on both sides. Finally, we move down to the flight management system, select the progress page, and verify that we've got GPS primary down here, which indicates that the GPS is the prime source for navigation at the moment, and verify that we see accuracy high displayed down here. Finally, we move down to the engine mode selector and make sure that it is in the norm position for most situations, or in the ignition start position if we are flying through severe precipitation where an engine flame out could possibly occur. Now, with all of that cross-checked, and when we are below 10,000 feet and cleared to an altitude with the QNH set, we can run the approach checklist. And the approach checklist goes as follows: Bajo reference, QNH 1008, seatbelts, on, minimum, barometric 550, auto brake, low, engine start selector, norm. Approach checklist complete. So by now the airplane has started reducing its speed to meet the 220 knot restriction overhead COPAC, and from there we are basically flying right on the extended centerline on towards runway 24 in Cologne. Now, at this point I will split this tutorial and we are going to start with the landing tutorial next, which will be a separate video, because then we can take a little bit of time to explain everything for the landing as we are approaching on the long centerline here. Therefore, thank you very much for watching. I hope that you learned something today. Be sure to leave me your feedback in the comments below, and if you're up for more, don't forget to subscribe to the channel. I would like to thank you very much for watching. If you really like what I'm doing, I would appreciate a small donation through the Buy Me a Coffee link in the video description below. Thank you for watching, and see you all again on the next one.